Right, we are looking at geometry 2-4, and again, this chapter has a lot of writing, and so instead of me taking up a whole video writing, I'm just going to show you the notes, and you can pause and write as you need to. So 2-4, deductive reasoning is what we're looking at today. And now deductive reasoning, draw a little arrow there, uses facts, rules, definitions, or properties to reach logical conclusions from given statements. So, from statements that I'm given, I'm going to use things that I know in order to make a logical conclusion. That's what this is saying. So, inductive reasoning uses a pattern of observations. And another term that we need to know is valid is true. Okay, so now let's do the law of detachment, and then we'll do an example here. So the law of detachment is a valid form of deductive reasoning, and it says this. So here's the words. If P then Q is a true statement, and P is true, then Q is true. So if this whole thing is a true statement, then we know that if P is true, then Q is also true. Now let's look at what that might look like. So hopefully you are pausing and writing down things and then unpausing and continuing on. So here is this first example. So here's what you're given. Here's what we know. If a car is out of gas, then it will not start. So if P, then Q. If a car is out of gas, then it will not start. And we also know that Sarah's car is out of gas. So my conclusion is, I know that if a car is out of gas, then it won't start. And I know that Sarah's car is out of gas, therefore, Sarah's car will not start because her car is out of gas. All right, hopefully that's fairly straightforward and makes perfect sense, right? Now let's go on to another example. So if two angles form a linear pair, then their non-common sides are opposite rays. So if two angles form a linear pair, that means when you put them together, there is a line that forms as their non-common sides. So it forms a line, right? But it also forms two opposite rays here, right? EB and ED. Now, you're also given that angle AED, and angle AEB form a linear pair. So we know that a linear pair, if two angles are a linear pair, then their non-common sides are opposite rays. And then we're just told that these two angles do form a linear pair. That means, so my conclusion is that since these two angles form a linear pair, then their non-common sides, so here's one angle here and here's the other angle here, their non-common sides form opposite rays. So ED and EB are opposite rays. All right. Now let's go on to this law of syllogism. This one, all of this stuff you're going to see again, but this law of syllogism comes back pretty often. So I'm pretty sure this is on the test, and anyway, it comes back quite a bit. So this is a form of deductive reasoning, and what this says is if P then Q and Q then R are true. So I've got P, Q, and R. If P then Q is true, and then Q then R is true, then P then R is true. So what I'm saying here is that if P to Q is true, and then Q to R is true, you can skip Q and go straight to R, P to R. All right, let's see what that looks like. Let's see an example. So here's an example. If you get a job, that's going to be P, then you will earn money, Q. All right, you get a job, you will earn money, okay? If you earn money, that's Q again, then you will buy a car, which is R. So you can say, if you get a job, you will earn money. If you earn money, then you will buy a car. And if these statements are true, then you can make a conclusion that is, if you get a job, you will buy a car. You will buy a car. So you can kind of skip the Q in a way, because if P then Q is true, Q then R is true, then P then R is also true. And that is 2-4, deductive reasoning. Sorry, that's a lot of work, a lot of writing, but that's how this chapter of geometry is. Good luck on the homework.